All right, students, we're going to pick up where we left off. You can see I added a little bit to the diagram from where we left off, as it's kind of difficult to get these counted correctly, and I wanted to make sure I did that. So we're going to represent the cardinal quantity of 56 as a base 5 number. So what we do is we look at 56 and we say, hey, can I make any groups of 125 out of that? Obviously not. There's not enough to do that. And I say, can I make any groups of 25 out of that? And yeah, I can do that. So this circle right here is one group of 25. So I'm going to kind of take that and scale it down and say, hey, that's a flat. Right? Remember, because our flats are 25. And then this one, I missed one when I was first doing the drawing. But this also is a group of 25. So that's one flat. Okay? And this is a group of 5. So that's a long. And then we have this one baby here. Okay? So when I am writing down this number, what I need to say is, hey, I have 2 flats. I have one group of 5. And I have one baby. Now, this looks like 211, right? That's if I am working in base 10, but we're not. So the right way to say this is 2, 1, 1. And then we have to let people know that we are using a different base. Right? So we write that with a 5. That's called a subscript, so it's a little bit lower. So 211 in base 5 is the exact same thing as 56 in base 10. Now we don't, traditionally write the 10 down here to tell people what base we're in because we're used to using that base. I'll write it here, but again, you don't have to. So both of these represent this cardinality, 56 units. These are the different symbolic ways to write it. Okay? All right, so we're going to go over here. We're going to do base 8. Hopefully it gets a little bit easier this time. So we are in base 8. What is the rate for composing and decomposing? Again, hopefully you're answering these questions. Maybe you're going to try to do this page on your own and then come back and watch the screencast. So we are 8 to 1. What digits do you need for base 8? You need 0, 1, 2, 3, 4, 5, 6, 7. What are our place values? So again, I'll make lines to represent where the digits go, and then I can label them. When I'm in base 8, always these are the ones. My exchange rate is 8 to 1. So when I gather 8 ones, I move them over, and I call them 8s. When I gather 8 eights, 8 eights is 64. Okay. Then when I gather 8 64s, grabbing calculator, I have 5 12s. And when I have 8 5 12s, I get 4 0 9 6s, 4,096s. Right? So my base pieces, my babies, are always 1s. I always have to have a way to record 1s. When I'm in base 8, though, a long is made up of 8 1s. So these are my 8s. My flats are made up of 8 longs, so they are 64. My shadows, my blocks, are made up of 8 flats, so they are 5 12. If I went to 2 shadows, which we said before isn't really a base piece, but it works for us, those would be 4 0 9 6. And I could keep going from there. Okay. So we're going to write the cardinal quantity of 56 as a base 8 number. I'm going to pause and do the circles around these objects. I'll be right back. Okay, so we're back, and what I did was I was looking at my 56 ones, and I quickly conclude there's no way in the world I'm making a 512 or a 4096. I'm also not going to get a 64 piece, but I can make some 8s. So I have grouped together 8 babies at a time here. So each one of these now becomes a long. Came out, exactly even. So I got 7 longs out of this. There are no ones left over. 7 longs is not enough to make a flat. I would have needed 8. So now when I go to record this number, I need to record that I have 7 longs, which are 7 8s. And then to make sure that people know that this is in the 8s column, I've got to put a 0 here to let them know I have 0 ones. So 7 8s is 56, and I've got 0 ones. So again, I need to tell people that I am working in base 8. So 70 in base 8 is the exact same thing as 56 in base 10. All right, going on to the next page, some more practice problems. Again, I encourage you to pause, give it a try yourself. Base 2 is craziness, but it's a really important base because computers are all based on base 2 at their root. We'll talk a little bit more about that in a minute. So the rate for composing and decomposing place value units, 1 to 2. What digits do we need in base 2? Well, we need a 0, and we need a 1, and that's it. What is the value of each place value in base 2? So I'll get some lines going here. Again, these are just standing for where my digits go. So I've got 1s, 2s, 2 2s are 4s. 2 4s are 8s, 2 8s are 16s, 2 16s are 32s, 2 32s are 64s, 2 64s are 128s. It keeps going from there. Okay, so when we have our base pieces, babies are babies. They're 1s. Longs, it's just 2 babies put together. Flats are 4s. Shadows are 8. Double shadows, 16. Put 3 shadows on here. 32. If I went another one, I would get to 64. So when I write this number in base 2 down here, it's only going to have 0s and 1s in it. That is it. So very quickly, talking about computers again. If you look at your on-off switch on your computer, most of you will probably see some kind of a symbol where you have a line, maybe kind of like a circle around it. The line means on, the circle means off. The line is a 1, the circle is a 0. So computers are based on circuits, and in circuits you have a series of switches, like light switches. They're on or off. And 1 means on, and 0 means off. And so all computer programming at its roots comes down to all of those light switches, if you will, inside your computer, and all of the different combinations of on and off that can be made in the computer. All right, I'm going to pause, do some circling here. All right, so I am back. I've done some circling, and I realized with only 56 ones, I could not make any 64s. I could get one group of 32, one group of 16, and one group of 8. So my 32, right, becomes that triple shadow. My group of 16 was a double shadow, and my group of 8 was a single shadow. So when I build my number, I'm going to be saying I have 0 ones, I have 0 babies, I have 0 longs, I also have 0 flats, which are 4s, I have 1 8, I have 1 16, I have 1 32. So this number 1 1 1 0 0 0 base 2 is equivalent to 56. So again, think this means 1 32 plus 1 16 plus 1 8 totals up to be 56. All right, now we're going to work in base 12, which is the highest base that I'm going to have you work in. All right, this one, just like with base 2, has a little weirdness to it, but we'll work through it. What is the rate for composing and decomposing? Got this by now, right? 1 to 12. What digits do we need? All right, so we need 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we've got a problem. So we do not have any other digits that we know of. It only goes up to 9. However, I am going to have to keep track of up to 11 items because my exchange rate is 12 to 1. I cannot write 1 0 to stand for when I have 10 objects because that uses 2 digits, and it would take up 2 place values and just totally screw things up. So we use letters. So when we want to indicate that we have 10 objects, we write a T. T for 10. Right? Hopefully you're guessing this. When we want to say we've got 11 objects, we use an E. So it's a single character, single digit, if you will. That's how we write 11. All right, so our place values in base 12, they get big really quickly. We've got ones. Our exchange rate is 12. So when we get 12 ones, we exchange it in for our 12s place. 12 12s is 144. And 144 times 12 is 1,728. And it keeps going from there. All right, so now I'm asking, what is the value of each base piece? So our babies are ones. Our longs are 12. Our flats are 144. Not that we're going to need it, but our shadows are equal to 1,728. Okay, I'm going to pause and do some grouping. All right, so you can see I was able to make groups of 12, and then I had some leftover ones. So when I write my number, I have 4 12s, and I have 8 ones, and of course that is in base 12. So 4 8, that's not 48, 4 8 base 12 is equal to 56 in base 10. That's it for this one.